All right, we are now looking at how to solve exponential equations. Okay, so again, exponential equations are something where the variable is in the exponent. So the first thing is there's several steps. Get the base by itself. Second, switch to logarithmic form. And then third, solve for x. Okay, so those are your three main steps. Again, get the base by itself. Once the base is by itself, we can switch it to logarithmic form. Okay, once it's in logarithmic form, we can then get x by itself and solve specifically for x. So let's look at number 1. 100x equals 1 over 10. First thing we want to do is get the base by itself. Well, the base is by itself on that side of the equal sign. So that step's already done. Our second step is to switch it into logarithmic form. So again, that's our circling around. So log base 100 of 1/10 equals x, right? Third step, solve for x. Hey look, x is already by itself now in this problem. So I'm just going to type exactly what this is straight into my calculator. So control log 100, and then 1/10 is in here. So I'm just typing it in exactly how it looks. And I get negative 0.5. You can also write that as negative 1/2 if you would like. But the calculator gives it to us as a decimal. So we're going to keep it as a decimal for the most part. And that's it. Next question, same type of thing. 2 to the x, right, is already, that base is already by itself. Swing it around, we got log base 2 of 7 equals x. X is already by itself. X equals, so I'm doing control log base 2 of 7. And we get 2.81. We'll round to the nearest hundredth here. X equals 2.81. We can always check our answers to the 2.81, and it's about 7, right? Again, that answer will be slightly off since we rounded this answer as well. All right, number 3, same type of thing, right? What's our base? All right, our base is 4. It has the exponent next to it. Okay, this is a longer exponent, but it doesn't change the fact that our base itself is still already by itself. So, again, looping around, that's log base 4 of 1 equals 2x plus 3. Now in this one, x is not by itself. I'm not going to use my calculator to the last step, otherwise rounding and everything, it gets off. So we want to wait to the last possible moment to put it in our calculator. So we're going to subtract 3. So all we have is log base 4 of 1. And this thing is by itself. Okay. I can't say 1 minus 3 is negative 2, right? This is part of the logarithm. This is not. And then we're going to divide by 2. So we have log base 4 of 1 minus 3 over 2 equals x. Okay. And now that x is by itself, we're going to type that whole thing in our calculator. So I'll start with the fraction. Then in parentheses we have log base 4 of 1, and that minus 3 is outside there. Over 2. Okay? And we got x equals negative 1.5. for number 4. We want to see if what our base is. Our base is what has the exponent. This 9 has an exponent. It is by itself already. So we're going to loop around. I guess I should really start at the 9. So log base 9 of 27 equals 2x minus 5. Okay. Now we're getting x by itself, right? So we're going to add 5. So we have log base 9 of 27 plus 5. And so getting this x by itself, so we're going to divide by 2. So we have log base 9 of 27 plus 5 all over 2. Okay? And none of this simplifies, right? This, if I ask for an exact answer, you're like, all right, I'm done. Okay, so that's why we wait until the last possible minute, because we want as little rounding as possible. No. This is being done. So log, I'll get the fraction first, and then the log base 9 of 27 plus 5 over 2. You'll get 3.25. Last 2 questions. We have 3e to the 4x plus 9 equals 15. So what's our base here? Our base here is just the e. Okay? It is not 3e. That 3 is, if it was in parentheses, it could be 3e. Okay? But it's just the e. So right now my base is not by itself. So I'm going to subtract 9. So I have 3e to the 4x equals 6. Then we're going to divide by 3. E to the 4x equals 2. Now that base is by itself. Now I can switch it. Okay? So this is log base e of 2 equals 4x. That's really the natural log of 2. Solving for x, we're going to divide by 4. So I have the natural log of 2 over 4 equals x. Again, you can't divide this 2 and this 4. This isn't natural log 1/2 or anything. Okay, this is the natural log of 2 and then divide by 4. So again, if it was an exact answer, this is what it would look like. But we're going to round. I don't know why this is not wanting to move. So we have, again, a fraction. And the natural log, if the log is here, the natural log is above that e. So control natural log of 2 over 4. We get 0.17. Problem number 6. 2e to the 2x minus 1 minus 7 equals 5. And that e is my base. We have some things we have to get by themselves first. I'm going to add 7. So 2e to the 2x minus 1 equals 12. Divide by 2. E to the 2x minus 1 equals 6. Okay. Make our loop, write it in logarithmic form. I'm going to jump right to, this is the natural log of 6. Okay. Again, for the same reason here, it's log base e, which is natural log. getting x by itself, I'm going to add 1. So again, this is natural log of 6 plus 1. That is not the same as natural log of 7. And same thing here, natural log of 6 plus 1 over 2. Again, not the same thing as like the natural log of 3. Can't do that. So x equals, let's just let this be good. Okay. So division, we have the natural log of 6 plus 1 over 2. I get 1 point, we're on it to 40. And that is it for tonight. Have a great rest of your day.